Question 24 again. Right, so with this one here, you've got your curve here defined implicitly, okay? And we need to get to ydx, we need to do implicit differentiation, okay? Because we've got y terms mixed up here with x terms. Now, notice here there's a product, right? And there usually is a product, so we'll go for the product first and maybe do it by the side. Yeah, so u is 8x, v will be y squared, du dx is 8, dv dx will be, well, 2y dy dx. Okay, so with the product rule then, this times this, v du dx, that's 8y squared, plus this times this, 8x times 2y dy dx. Okay, so that's the product rule there. Differentiate this then, y to the power 4 becomes 4y cubed dy dx, of course, because when you differentiate with respect to x, okay, you've got, this is a y function, so you do it with respect to y first, and put a dy dx on the end. Take away then, this becomes 4x. This then you've already got over here, so that's 8y squared, plus then, well, 8x times 6, so times 2y is 16xy dy dx. And then plus 9, well, that goes, so that equals 0. Okay, so then we get the dy dx's together, okay? So put them together like that. Just factorize the dy dx's and take any of that stuff over to the other side. So that becomes 4x minus 8y squared. And then to get dy dx, take that over and divide. Now we haven't got quite what they wanted. What you're going to need to do is divide the top and bottom by 4 because it's a common factor. Okay, you could factorize out if you want 4 there. Factorize out 4 on the bottom. They cancel and you get exactly then what they want. Okay, so that's your answer then for part A. Part B, it says show that there is no point in this, no point on C at which dy dx equals 0. Okay, so show there's no point on C at which dy dx is 0. So if you think of dy dx as 0, that's when the tangent would be parallel to the x-axis, wouldn't it? Because dy dx is 0, we think about stationary points. So it's when the tangent is parallel to the x-axis, when you've got maximum, minimums, and point of inflections and so on. So you can think of it like that. Okay, and they say here, well, it isn't a point that exists for that. Well, what we'll do is, we'll actually, to prove this, we'll actually assume the opposite, right? So we'll assume there is a point, okay, on C such that dy dx equals 0. So we're doing this, because if you assume there is a point, we can show them, well, actually, no, it doesn't work. So if we put dy dx equals 0, okay, the expression we had from A, but this equals to 0, well then all of this then the bottom, because it sort of disappears, because if this is equal to 0, then the top is just equal to 0. Okay, you can think of this bottom, taking it over and multiply by 0, and it just goes. So you get then x then equals 2y squared. So you've got an expression for x in terms of y, right, which is handy. So what you do then is you substitute it into our original expression. Okay, so if you remember the original expression for the curve, or the original curve, sorry, is y to the power 4. Okay, all of that stuff. So you put in then your substitution, you substitute x in. So keep y as it is, but x becomes 2y squared. Okay, so in this case, because I've got to square x, I'm going to put 2y squared in a bracket and then square it there. Plus then 8x times y squared plus 9 equals 0. This becomes y to the power 4. Square that bracket, well that becomes 4, and y to the power 2 squared, you times the powers. Multiply this out, so you get 16y to the power 4, add the powers there when you times in terms. This becomes minus 8y to the power 4. And then work that out, you've got loads of y to the power 4 here, that becomes 9y to the power 4, plus 9 is 0, okay. You can divide by 9, so y to the power 4 plus 1 equals 0, and that's impossible, isn't it? You can't have that, y to the power 4 plus 1 equals 0, because y to the power 4 must be greater than or equal to 0. Okay, it's like squares, a number that's squared has got to be positive. Well, a number to the power 4, it's got to be positive, because y to the power 4 is just is like squaring something that's already squared. That's what it is, isn't it? Y to the power 4. Okay, think about it like that. It's like y squared, all squared. So it's definitely positive, isn't it? Definitely positive. So if that's positive, and you add 1 to it, you can't get 0, can you? Because if you're adding 1 to it, it's going to be even more positive. Okay? So this then is impossible.